Alright, so this is a video to go over pH and pOH. Generally speaking, right now, early in the school year for AP Chem, for strong acids and bases because they ionize completely. But these concepts are true even when we do the week, just only partial ionization. So first thing you need to know is that pH and pOH come from concentrations, and concentrations are usually put in brackets and represent a molarity, moles over liters. And what we're finding the concentration of is hydrogen ions and hydroxide ions, or acids and bases. So we're going to get this pH and pOH from those concentrations. Another thing you need to know coming into these calculations is what the water constant is. So Kw is a shorthand symbol for water constant. It means when water breaks into its hydrogen and hydroxide ions, it comes into equilibrium with them. So it looks a little something like this. H2O is going to go into H ions plus OH ions. So these two ions are in equilibrium with water, so that's why it's called the water constant. Okay, and we can write that into an equation. What we find, since water is neutral, we can find that equilibrium constant is always 1 times 10 to the negative 14. So this is a given known equation that we can use if our hydrogen and hydroxide are not 1 times 10 to the negative 7 for each ion. The other thing we can then do is say, all right, how can I find pH from a hydrogen ion concentration? To find pH, it's basically the power, all right, or the exponent. So if this is 1.0 times 10 to the negative 7, then the negative log of that hydrogen ion concentration would give us a pH of 7. If hydroxide for water was 1 times 10 to the negative 7, we could take the negative log of the hydroxide concentration, it'd be 7. So that pH plus pOH always equal 14. So you can see the relationship right there. Okay? So what if we're not dealing with water? What if we're dealing with a strong acid or a strong base? Well, these values are not going to be 1 times 10 to the negative 7 and 1 times 10 to the negative 7. So we are going to have to use these equations for our different values. You can find hydrogen ion concentration if you're given hydroxide concentration by dividing that OH into there. Or if I give you the hydrogen ion concentration, you can divide it into the water constant to find the hydroxide ion concentration. But there's a second way you can find those concentrations. If you are given pH or pOH, so be careful. So, you know, maybe they're giving hydroxide, right, and they want pH, so you're going to have to do a couple steps. But if they give you those, all right, those pH and pOH, you could just take the inverse log, so the second function on your calculator, and make sure you have negative for the values. If they give you a pH of 7, put negative 7 after that inverse log button. Same thing with OH. So let's do a practice. So this is just an overview. Most of this is in your PowerPoint, so most of you are understanding it pretty good. All right. But let's go ahead and do this problem. Find the pH. So the key thing is we're finding the power of hydrogen. So we want the power of hydrogen. Okay. And what do they give us? They give us molarity. All right. So molarity is the same thing as a concentration of sodium hydroxide. Okay, this is a strong base. That's important because we know all of the ions of the base, which are the hydroxide ions, are equal to that concentration. So there is your understanding. So I basically have the concentration of hydroxide. That's what they're giving me. And I want to find the pH. Okay. So there's a couple ways to solve this. The first way is you can get your pOH, all right, by taking the negative log of this hydroxide concentration. So, and this is probably the easiest way. So you can have your calculator out, and you can put 0.000298, right, that's our concentration. And what we're going to do with it is we're going to take the log of it. 0.000298 equals, and it gives you a negative value, so just multiply that by negative in your head, so it's a negative log, so that's 3.52. Okay, so this is a pOH is equal to, the pOH is equal to 3.52. So the pH, what we're looking for, is going to be 14 minus 3.52. 14 minus 3.52. 10.48. So our pH equals 10.48. So we know this is basic. You already knew it was basic because the pH was low, and if you have a low the pOH was low. And if the pOH is low, that's the pOH scale. And so when you go small, it's more hydroxide. So that is one way. The other way to solve for this is that I give you the hydroxide ion concentration. You could go ahead and divide it. You could divide that value 0.00298, all right, concentration into the water constant and get the hydrogen ion concentration and just take the negative log. So let's try that. All right, 0.00298, 1 second EE negative 14 divided by 0.000298. Okay, and then we'll take the log of our answer, and look at that. There is the pH. So that's the other way of doing it. So that's just a quick little tutorial on the key equations and an example problem for how to do pH.